Hello, and welcome to my first episode in the series Let's Build It. In this series, the aim is to learn new stuff while we build something custom together from scratch. In this episode, what I want to build is a simple hook, a custom hook for React that's going to make use of some of React's built-in hooks in order to expose us a state variable that is also stored inside local storage. This is going to come in very handy if you ever have to store things like, for example, a token when you register or log in to a website. Or you might think even of other purposes for this hook. And you'll see that we're going to implement it in a way that if we ever change the value of our state variable, it gets updated in every tab that's open with the application. So let's get started. In order to understand what we are going to build, we need to understand what is already here in our application. I'm using a typical Create React app. With a little bit of customization, I've removed all files which I didn't consider necessary, or most of them, and I've also updated the app.js file and the app component so that we can actually test our hook out. The hook we want to build is going to have a signature very similar to useState, the built-in hook that React provides us. useState is one of the most used hooks in React. useState's role is to store a state variable, internal component state, in a way that we can rely on that state between component re-renders, and also if the component state changes, we want the component to re-render based on that new state. But if we do want to store a value and retrieve it from local storage, then we need to implement a lot of functionality around this, and we don't want to do that every time we define a component that needs that kind of functionality. So in order to make our life easier, we are going to create a custom hook that we are going to be able to reuse in all the components we want to. How does useState work? Because we want to emulate it as much as possible. Well, useState, once invoked by a component, is going to return a tuple or an array. The array contains a state value, a state variable, and the second thing it contains is a function to update that state variable. useState also can receive an initial value that is going to be set on this state variable the first time our component loads, or the first time that our hook gets invoked. This initial value is special. Why? Because you could pass a static value to it, or a normal value, a variable or a literal value. You could pass it, and it would be stored in state, and it would work. But you could also pass it a function. The function, as in this case, will return a value for the state variable. In our case, it just returns a random value. The advantage of sending a function as the initial value is that this function is only ever going to be run the first time useState gets invoked. This ensures that if we have any expensive computations, our component does not get slowed down. We will need to implement this kind of functionality in our own hook when we try to emulate useState. The other two invocations simply make use of arrays and objects, just so that we can see that we still maintain some of the functionality that useState has, and we can actually store other kinds of data besides only primitives inside our state variable. If we go further down in our component, we see that each of these three buttons actually has a function that sets a new value in state. I've set up random numbers here so that we can see that if I ever refresh this tab, the values change every time. They also change, of course, if I ever click these buttons. So if I click this one will change. And we can see that it will go down. This is because of how setValue works. If I click it again, it goes down, and if it reaches 0, it will never go back up again. This is because setValue, if it ever receives a function here, it will invoke that function, passing it the current value. The way our getRandomNumber is set up is that it receives a maximum number up to which it's going to return a random number. And if we pass it the old value every time, the old value for our number, obviously it's very likely that this number is going to go down every time we click the button, because the maximum is always going to be a number that's smaller than or equal to this maximum value. So in the best case, we're going to end up with the same value twice, but it's not happening right now. It always goes down and it never comes back up again because of this. The other onClick handlers just invoke the functions normally and use those values. So if we click them, we always get a different value. And it's nice that we get a different value because we can see that this always updates. One last thing I've done is I have another tab open with the same data, with the same application. And in this case, we see that it's the same situation. The two tabs are not kept in sync. This is another thing I want to achieve with our hook. I want to keep these two tabs in sync. So let's get started. Let's develop our custom hook. The first step is we're going to create a new file. We're going to call it useLocalStorageState.js. And there is one recommendation you want to bear in mind when you're creating your custom hooks. Custom hooks are just functions like useState is, and we've seen useState. When you create your functions, your hook functions, you want them to be named starting with the use keyword. And we're going to name it the same as our file, useLocalStorageState. Of course, if we want to imitate setState or useState, sorry, we want to pass it an initial state. And we want to return a state variable and a setState function. If we want to manage state, it's always a good idea to actually use state inside of our hook, because React already has everything built in to manage state. So we're just going to use useState, but dress it up nicely, I guess. So we're going to pass useState the initial state that we received ourselves. And we're going to rely on the fact that useState will return an array with a state variable and a setState function. We need to import useState. We're going to use VS Code's functionality to do that. And we're going to export our useLocalStorageState function. This right now is a hook that perfectly emulates useState because it only exposes the exact same interface to the programmers. But we don't want it to only do this. We want every time somebody sets a new state value, we want to store that state value inside local storage. We want to return our own function that will store the value in local storage while also setting the state variable. We're going to define that function inside of here, inside of our hook, and this function is going to be called updateState. Our updateState is going to receive a new value. This new value, as we've seen with setState, could be a function or it could be a static value that we can use directly. We're going to have to check for both cases. What we want our updateState function to do is we want to first store our value in local storage. After storing our value in local storage, we want to set it inside the state so that we update the state. Of course, now we don't want to return setState anymore here. We want to return updateState. Let's create the logic necessary to store everything inside local storage. You might want your hook to be able to be used in a server context. Maybe you're using Next.js, maybe you're not using React. So you might want to check if you have window.localStorage available to you before you use this. That's what we are going to do right here. If we have window useLocalStorage. And bear in mind that if you don't have window, you don't have window.localStorage either. So we might want to check if we have window as well. And you could do this the old-fashioned way, if window and window.localStorage, or you could do it with the optional chaining operator that we have in JavaScript right now. Optional chaining, what it does is that if this is undefined, it will not try to grab local storage from it. It will just replace this expression with undefined completely. So if either of these is undefined right now, we would get an if undefined, so we would never enter this condition. If we do have local storage available to us, we want to use it. Window.localStorage.setItem. And when you set an item, you kind of need a key here, but we don't want to hardcode this. What if our hook is going to be used like 10 times? We can't have the same key 10 times inside local storage. We need a unique key, and we want to leave it up to the programmer what they want to call this key. So we might need to receive this as an additional parameter inside our function, and we're going to use that parameter here as well. So we're going to set item with this key, and we're going to set the new value. This is the simplest implementation that we could do, and after everything is said and done, we just need to set the state to the new value. This would be really the simplest way to do this. But as we've seen, this new value can be a function. It can be a function, and if it is a function, we would want to treat that specially. Also, what we might want to do is that if ever this new value is undefined, we don't actually want to set undefined in local storage. We might want to remove the item from local storage. So we give the programmers an option to actually delete their local storage values if they ever want to do that. And we could do this the following way. We could check if new value is different from undefined. And this is just an exclamation mark and two equal signs. This is just my font ligatures kicking in. So if new value is different from undefined, then what we want to do is window.localStorage remove item, and we just pass it the key inside here. Otherwise, if it's something different from undefined, we might want to set it. And we want to remember something else too. We do set objects and arrays in local storage. Local storage only supports strings, so we might want to serialize this value to make sure that we can store complex types inside local storage. To serialize this value, we're going to use our simplest method available to us in JavaScript. This is json.stringify, which actually turns any kind of object or primitive value into a string that is valid JSON, and we can use that valid JSON afterwards. Let's close this so we can see more of our code. Then we set the state to the value that's not stringified, which is also great, but we do have a problem. What if new value is a function? We cannot stringify a function. Also, remember setState can handle functions, but at the moment we don't handle functions at all. So what we would need to do is determine what the new value actually is and maybe invoke the function ourselves. So we could do something like if new value is of type function. So we're going to check the type of this. Type of new value is triple equals function as a string. If it is a function, we want to invoke new value. And not just that, but remember that setState sends the current value of the state variable to this function in order for the function to be able to compute the new value depending on that. And we could send it in here like this, like so. We're going to see that this is not actually optimal. We're going to change it a bit later on. We'll see why. It's not good to depend on your state variable whenever you are going to change that same state variable. It's not a good idea. So we're going to come back to this. But for now, to keep the code simple and understandable, let's do this. And I'm going to say that new value is equals to whatever this invocation returns. So we get our new value, we set it in local storage, and then we set the state to this new value. This should already work. We might use this little bit here a few more times. So it might be a good idea to extract it to its own function. Let's do that. We're gonna go up here. We don't actually need this to be inside the useLocalStorageState hook. We can declare it as a separate function and say set storage. Let's keep it simple. Set storage. And we're gonna have this inside, only this logic that says the local storage. But of course we do need a value. Let's call this just value. Value singular. We're gonna have the value here. And we do need the key as well. So we're gonna receive the key and the value. And we're gonna set the storage to whatever our value is, except if it's undefined, in which case we're gonna remove the item with the same key. So we're gonna move down here and say set storage, and we're gonna pass it the key inside here and the new value. Perfect. So we've extracted this logic because I have a feeling we're gonna use it again because we have to use it for the initial state as well. This is almost perfect as an update state function, with one key exception. useState always ensures that our update or setState functions, these functions right here, always have a stable reference in memory. They never change when a component re-renders. We need to ensure the same thing for our hook. We don't want this function to be used as a dependency for a useEffect or anything else, and we don't want it to change its reference in that case because it would trigger a rerun of the effect or of the callback or anything. So we want our reference to be stable, exactly the same as setState. But at the same time, we do depend inside of it. We do depend on a couple of state variables. We depend on the key and we depend on the state. So we kind of need to define it inside our useLocalStorageState hook. We cannot define it outside of it. But we also want a stable reference, so we don't want every time this function gets rerun, which is every re-render, we don't want this function to be created again. This is why React actually provides us with another hook. It's called useCallback. And useCallback, its sole purpose is to create functions which have a stable reference in memory as long as none of the dependencies the function has change. We need to import useCallback, and we've done this automatically up here. The first thing we pass useCallback is our actual callback function. It would be something like this. We can just use this function right here. I'm gonna cut everything here and I'm gonna go here and paste it in. We need our arrow back. So our function still receives a new value, but we still need the curly braces because we have more than one line inside of it. And what we also want to do is use this name to identify our function. But this time the function is returned by useCallback. So we're gonna just declare a new constant here, the same name, and grab the value that useCallback returns, which is gonna be our callback function. But we do have one issue, and that's why useCallback is right now underlined with a squiggly line. We use inside of useCallback two state variables. The key, which is an input variable, we depend on it. It's kind of our hook's state, internal state if you want. It's an input. And we use this state variable right here, which is actually a state variable. We can see it. What we need to do is tell useCallback that it depends on these two. If these two ever change, this function, this whole function right here needs to be updated. So we need to pass it as a second argument, a dependency array that is composed of both variables that we use inside the function. And of course, I cannot type while I speak, or at least not correctly. But here we see a problem. We depend on the state variable, but we update the state variable inside this function. This means every time this callback runs, it's going to update the state variable. Since the state variable got updated, this callback is going to have to be updated. So useCallback creates a new function reference. So we've actually improved nothing. We still get a new reference every time the state updates. This is not ideal. We want to lose this dependency from here. We want to get rid of it. What we can do to get rid of it is rely on the way setState works. Because we've seen that setState can receive a function to which it passes the current value of the state, but it never ever mentions the original state variable's name. So let's try to use it. Let's try to refactor this to use setState. So we could say setState from the beginning, but instead of passing it the new value, we're going to pass it a function here. And it's going to be an arrow function. And this arrow function is going to receive the current state, which is this. But it's a local variable to this function. It's not one of the state variables of the useLocalStorageState hook, which means that we can move this code, this bit of code inside of here. And instead of relying on the variable named state in here, we can rely on current state, which is not a problem anymore. And by relying on current state, we have suddenly given up any kind of reliance on this state variable. Current state is local to the function, which means that we don't have this external dependency anymore. We only depend on key. If the key changes, we want this function to update, and yes, that makes sense. We do not change the key inside of this callback. We only change the value. So now we don't have any kind of circular dependency or anything like that inside. Our function is now clean. Not only that, but useCallback also returns us a stable reference that won't be updated between re-renders. And this is what we pass to our component. This is more or less done. Now what we need to do is do the same thing or something similar for the initial state. How we're going to do that? Well, the same way we did it right here. useState, as we've seen, also can receive a function instead of just a static kind of state. So we're gonna pass it a function. And inside this function, we want to set the state, the initial state. If there is something in local storage, we want to grab that and set it on the state variable. If there's nothing in local storage, we might want to use this initial state, and this can be a function or it can be a static value. First, we need to check if there's something in local storage. So we need to check again if we have local storage available to us. We're gonna copy this over here. Now, if there is something in local storage, we're gonna create a new constant to store that in. We're gonna call it from storage, and we're gonna say window.local storage get item, and we're going to use the same key we used previously. And remember that if we store something in local storage, we store it in JSON encoding, so we need to parse that JSON parse this. Actually, no, we cannot parse it here. We need to see if there is something in local storage for this key. And if there is, then we're going to parse it. I'm going to replace this with let. And if we have something from storage, we're going to say that we're going to return. Actually, I could have left it as a constant. We're going to return JSON.parse from storage. Why do we check this? Because getItem will return null if it doesn't find anything. So if we return inside of here, we of course don't need this to be a let. We can leave it as a const. And we just return that. If we do not have local storage available to us, or if there was nothing in local storage, we're never going to hit this return, and we can move down here, and we don't need an else statement because of this return, but we can continue with our initial state case. So if we don't have something in local storage, we can use our initial state, but we need to check if initial state is a function, same as we did below. So if type of initial state is a function, and this is a string. So if the type is a function, what we need to do is invoke that function and get our state from there. So we're going to say default value is initial state invoked. Otherwise, or we can, I think we can avoid this else statement if we go up here and say simply that our default value is going to be the initial value. By default, it's going to be the initial value, but if the initial state, initial state, I wanted to. So the default value is the initial state. If type of initial state is function, then we want to replace the default value with whatever the function returns. So this needs to be a let this time. And we made sure that default value is always correct. What we need to do next is return it at the end. So we either return whatever we get from local storage, and this will be set as our initial state, or we return whatever was passed as an initial state, but after we've executed it, if it was a function. If it wasn't, we just return the value that was stored there, or that was passed us there. This should take care of this bit. And now I think we have a fully functioning hook. We might not need to do anything more, but test it out. In order to test our hook, we're going to replace every call to useState in our app component with a call to the useLocalStorageState hook. We're just gonna auto import that, and we're gonna copy and paste this call to every other line where we used useState, and we can remove useState. But don't forget, useLocalStorageState also needs a key, and we are going to set a key here. We're gonna say something 1, and we're just gonna increment that number as we go further down into our code. I just don't have any kind of inspiration when it comes to naming these right now. Perfect. We get this error if we let the application refresh, and this happens because I have a small mistake. I've created my file in the wrong place. Let me move this to the sources folder. I'm gonna close this again. and we need to import it from the same folder. See what happens. And we have no more errors. This is perfect. First off, we get these values as we previously did. And we see they're different in each tab. Okay. This is maybe because of how we loaded everything up. Let's see what we get in our DevTools in local storage. And we have nothing inside local storage. This may be due to another error I have right here. But we never actually set the local storage state. If we didn't get here, we don't set it. We might want to do that. So let's set storage here and spell it correctly. Set storage, and we want to set the same why am I doing this here? I want to set the same value that I return, default value. This should work. Let the application refresh. Oh, this is not right. We still have a couple of errors in our code, apparently. So let's check. Our first parameter is the key. And we pass it along. Oh, we don't pass it along, actually. I misused my function. So we pass the key and then the default value. We should clear the local storage and refresh again. Forcefully refresh. We have one last error, of course. We check if the value is not undefined, and in that case we remove the item. This is obviously wrong. We need to move this here and this to the else statement. We want to set the item if the value is different from undefined, and we want to remove the item if the value is undefined. If we now refresh, okay, we get something 1, 2, and 3, and they seem to be the correct values. And we have 2. In case of our object, we have this one, JOFCK, and in case of our array, we start with BH13. If we go to our other tab, it hasn't refreshed yet. I'm gonna refresh it now. And we see that we indeed now have the exact same values between the two tabs. We can also test the other functionality. We can set the value as function. This will update this little line here. We go to 1. Local storage is updated. If we refresh the other tab, we should see a 1 here as well, but I have to refresh the tab. If I set an array, we update this little line here, and we see that the local storage has also updated. We have 29, 27, and a string. And if we set the object, we update this one. Something 3 also updates in local storage. And of course, if we refresh this tab, we get the new values. So our hook finally works. We ironed out all the kinks, I think. So let's move on. I said in the beginning that I want both tabs that use the same component to update once we set something new in local storage. We can do that by using a JavaScript event listener, a normal event listener that we set up to listen on the storage event. The storage event gets triggered on the window, so it's completely outside of the scope of our component and of our hook, of course. If we want to affect something that's outside the scope of our component, that's outside the scope of our hooks, we should take care, because that is called a side effect. Side effects in React should be handled using the useEffect hook. The useEffect hook is one of the basic hooks that React provides us, and it's a very powerful hook at the same time. It allows us to sync up state. For example, state that is in the browser, let's say in local storage, and state that is inside our component or our useLocalStorage hook. so we could do a sort of syncing if we wanted to. It also allows us to set event listeners on something that's not in the scope of React, like window or document. useEffect also allows us to have asynchronous requests, so basically sync up the state of a server with our internal component state. So it seems perfect for our use case, because what we want to do is set an event listener on window, and once that event listener is triggered, we want to update our local state inside our hook. Let's set up our useEffect hook. useEffect. Remember to use all your hooks, all your custom hooks and all your default React hooks. Use them in the root of your component and in the root of your hooks. Don't use them inside if statements or inside loops or inside other functions. Use them in the root of your hook, in the root of your component, because otherwise they will not work. We have to import useEffect. I'm gonna auto import it again, and we see it up here. useEffect is also a function like useState and our own hook, and what it receives as a first argument is a function. This function has to describe our effect. In our case, what we want to do is to set on window an event listener. So we're going to add event listener. We want to listen for the storage event, an event with the storage type. And our listener will be a function. But because we will at one point want to tear down this listener, we want to remove it from window when our component gets unmounted. If we want to remove an event listener, we have to know what the reference to our function is, what our function is in memory, because we want to remove only our function from the list of event listeners. So what we might want to do is create this function separately. We're just going to call it something like onStorage. We don't have this function yet. As another recommendation, when you use useEffect or useCallback, any kind of functions you want to define and you need inside the effect, it's recommended that you define them inside this function right here. This is because this way ESLint, our local linter, is going to help us in case we forget any kind of dependencies. It's impossible for a static analysis tool to discover these kinds of dependencies if they're scattered around our code, so defining them inside here will help a lot. So we're going to define our function right here. We're going to say function onStorage. And this function is going to get an event object like any other event listener. And what we want to do is, of course, grab the new value. Actually, we have that new value here on the event object. We can grab it like so. And it's just a matter of setting the state to this new value. This should take care of everything, because the moment our value changes is inside this function, inside the update state function, and it's already being set inside local storage. So that's why this event listener gets triggered in the first place, and we just want to set it on the local component state. That's why this is sufficient. But we have to take care. In our example, we have at least 3 invocations of this same hook. We don't want, for example, if we change this one, we don't want to trigger the listener for this one and the listener for this one. We only want the listener for this particular value to be triggered. How can we identify the one that we need? Of course, by using the key. So what we want to do is not always set this new value, but instead we want to check if the event key matches the key that our hook received. And only then do we want to set this value. And this might be enough, but as I said, we do want to tear down this effect. We do want to clean it up after it runs or after the component has been unmounted. To do that, useEffect allows us inside this function here to return another function, a cleanup function. So what we want to do here is to remove the event listener. Window, remove event listener, and we're just going to say we want to remove something from the storage event, and that something is going to be the onStorage function. It has to be the same reference as the one we added. And what the other thing we want to be careful about is, do we actually have window here? We might want to use the same optional chaining operator that we used previously. So in case window is undefined, then just nothing is going to happen on this line, and neither will it on this, and onStorage will never run. So our effect should be clean enough this way. There is one more thing that we didn't cover with useEffect. Right now, this effect is going to run every time our component re-renders. This means every time a state variable changes, this effect will run again. This is not something we want. We don't want to add this many event listeners onto window. We only want the one event listener. Or actually, we wouldn't add many event listeners because we clean them up every time. But why clean it up and add it again if it's just going to be the same thing? This is why useEffect allows us to specify, same as useCallback, an array of dependencies right here. And as we see, the array of dependencies is being underlined with a squiggly line right now because we don't specify a dependency we have. And the dependency is the same as in the case of useCallback, it's the key. We use this key inside the effect. So we're just going to specify the key here. This should fix our dependency. This time, useEffect will only run the first time when the hook is invoked, and every time the key changes, which won't happen. But if the key changes, the effect will run again. And it makes sense to run again because then we would want the key inside this function to be updated as well. If we clean the local storage up and we refresh, we get a new local storage. It's already synced up between the objects with one little exception. Our object here, between tabs, sorry. Our object here doesn't seem to have been updated. And right here what we get is a weird array. This of course happens because, as we know in our local storage, what the thing we store is the JSON stringified value. What we want to do here is parse that. JSON.parse the value that comes in. This should fix our issue. Let's refresh both tabs. I'll refresh this one. We should see the values which are right now in local storage, and we do. We'll refresh this tab, although this already displays the correct information. I'll just refresh it, and we see the correct information again. But now, the thing we want to test is if this synchronization works between tabs. This means that when I trigger an update here, it should be reflected in the other tab instantaneously. Let's separate this tab out so that we see them side by side. I'm gonna click the button that updates this first line in both cases, and it will update the local storage as well. 10, 10. It got updated instantaneously. Let's see the array. It's this last line. Instantaneous update, both places, and object, instantaneous update. It works both ways. We can update either one, and it works almost perfectly. We get a different value here than we have here. Arrays seem to be working. Objects seem to be working. But when we pass a function into the setState method or function, we get unexpected results. Let's check why that is quickly. So most of our hook seems to work, except for this one little bit here. So every time we call our updateState function, which is this function right here, this little one, we pass it a new value. The mistake we have is that we actually set state twice right now. We shouldn't ever do this. This has to be removed, because what setState expects here is that we return the new value. So that's what we messed up. Return new value. This should fix it. Let's see if this works. We should separate this out again. Let's check. We separated it out. Let's refresh both tabs just to make sure we have the exact same state in both of them. We're gonna set the value as function, and we see 21, 21, and this should decrease as we go. It should never get back up from 0, which it doesn't. We can set the array, and we see that it updates in both places, and we can set the object, and we can see that it's in sync in both places. If we were to delete this just to test it again, because this was the problematic one, we already had an update. There's nothing there. Let's refresh, and we get 28, and we should see it decreasing as we click this button. 27, 10, 6, 4, 0, and it never gets back up again. Okay, perfect. Our hook seems to work. As a recap, what we have done, we've implemented this useLocalStorageState hook. It's a custom hook. It has to start its name with the keyword use. We have to export it, of course. We receive a key and an initial state as arguments. The initial state can be a function or it can be a static value. We check for this inside the function that we pass to useState. If it's a function, then we run the function and we get the default value back, and we set that. Otherwise, we just set the static value that we received, and this is the simple use case. We have to remember to, of course, set everything in local storage. We have to set a new item with the correct key and the correct value, which we have done here. In this function, we only check that we do have local storage and window available to us, and in that case, should the value be different from undefined, we set the item in local storage. Otherwise, we remove the item from local storage based on the key we got. If we set the item, we stringify it to serialize it in case it's an object or an array. Otherwise, yeah, we don't need the value. Same with the initialization function here. Besides checking for the initial state, if we do have something in local storage and we have local storage available, we try to get that item. If it's there, if it's not null, we just return as the initial state whatever we got from local storage. Of course, we parse it first. Moving on, when the function we expose for programmers to be able to update our state variable is this one. We've used useCallback to ensure that update state always has a stable reference in memory, so that it's not required as a dependency to use effect calls or anything like that. Our function simply sets the state to something that is returned from this function inside setState. We've used this notation because this way we can eliminate one of our dependencies, as we've seen. We just receive here the current state, which we can use if the new value that we receive from the programmer is a function. We just pass the current state to it and get the new state, the new value for the state, back from this function. We set it in storage. If it was a function, we get the value from here. Otherwise, the new value is just going to be whatever the programmer passed. We set it in storage with this function up here, and then we return it so that setState sets the state to this value. And then we wanted our two instances of the application to be in sync. We've done this using a useEffect hook. In this useEffect hook, we've created a new function called onStorage. That's the event listener. Our event listener checks if the event key was equal to the key that we actually received when our useLocalStorageState hook was invoked. And if it's the same, then we set the state to whatever that value is. Of course, we parse it first. We set up the event listener. We listen on the storage event. When the component gets destroyed, or if the effect runs again, we want to clean up whatever the effect did. So we remove the event listener from the storage event, the same listener. This should ensure that everything is clean and only happens once. Of course, both useEffect and our useCallback hooks make use of the key variable that we have as an input to our function. We have to make sure to pass this key as a dependency to both the hooks. This is it. This is how you would implement such a custom hook. And this wraps up our first episode in this series. I hope you enjoyed it a lot. If you did, please subscribe, maybe like this video, and come back for our next episode. I don't know what we'll be creating together then, but I hope it's interesting for you and you'll be here for that as well. See you next time. Bye.